A very good afternoon to everyone. Thank you so much for being connected with us. Now, I would like to introduce our next keynote speaker, Dr. Vishal Krishna Singh from Indian Institute of Information Technology, Lucknow. He is currently engaged in various ongoing life projects and have varied publications in journals of repute. So, I request you to deliver the invited talk on the topic software engineering.
Thank you so much for inviting me to this session. And I'm very pleased to be part of this international symposium on recent advancement in information and communication technology, which is being organized by the Integral University, Lucknow. So, yes, today we shall be, I'll start with a brief introduction about myself. As ma'am was just mentioning, I'm Vishal Krishna Singh and I'm an assistant professor in the Department of Computer Science in Indian Institute of Information Technology, Lucknow. So today we shall be talking about machine learning and a few things apart from the fundamental concepts. We shall be talking about bias and fairness as well. So I hope my voice is clear and the screen is visible to all of you. So with this note, I'll turn off my video camera so that it is not much of a disturbance at my side. So I'll share my screen and I'll turn off my video camera so that we can continue with our discussion now. So having said this, okay. So good afternoon, everyone. Today, I'll be presenting a brief introduction of machine learning. We shall be talking about bias in machine learning, and we shall also talk briefly about the possibility and the ideas, possible ways precisely to achieve fairness in machine learning algorithms. Right. In the next hour or so, we shall cover the following topics, which, as you can see here, are mentioned as the outline of the presentation. We shall start with an introduction to machine learning, the fundamental concepts of machine learning, the applications of machine learning, the methods of machine learning. We shall also discuss the machine learning algorithms with the real world, some of the real world examples. Uh, we shall also cover the concept of fairness in machine learning with a brief introduction to the concept of bias in data. We shall cover algorithmic fairness and also the concepts of fair machine learning. Now, we will conclude the session with some of the challenges and the possible research opportunities for the curious researchers working in this domain. So, before we delve into the details of fairness and the related concepts, let us first try to understand the fundamental concepts of the meaning of the term machine learning. So, the first and foremost question is, what is machine learning? So, to answer this question, or the answer to this question can be understood from a very simple fact that and this fact is quite evident to all of you. Maybe you'll see and you'll realize that uh, it is quite obvious that it is very hard to write programs that can solve complex problems of the human mind, right? For example, consider the example of a recognition of a face. And why do you think this is a difficult task for a programmer to write such a program? Well, this is obviously a difficult task for the programmer because we don't know what program to write, because we don't know how our brain does it. Or let us say that even if we had a good idea about how to do it, the program might be very complicated, or it will take a significant contribution of our work, of our time, of our involvement in this process to write such a program. So instead of getting involved into all this, what we can do is, instead of writing a program by hand, what we can do is we can collect lots of examples that specify the correct output for a given input. And to this end, a machine learning algorithm then takes these examples and produces a program that does the job, right? So the program produced by the learning algorithm may look very different from a typical handwritten program, but it may, for instance, it may contain millions of numbers and all those things. But the thing is that if we do this right, the program works for new cases as well as the ones we have trained it on, right? We have executed the program on the training set, we have tested it, and once we are done with this, or once this entire process is done correctly, so what we are hopeful that this algorithm or this program will be able to work on new data sets which can be used for on which this method or this algorithm or this technique can be tested. So basically, all the things which I just said can be realized from this picture on the screen. If you can see, you see that in traditional programming scenarios, what happened was that you provide the data to the program and you provide the data and the program to the computer to obtain the desired output. However, as I just described, the machine learning scenario allows the computer to learn from the data samples to the desired task of the testing samples, right? So you can see the clear distinction between the two computing scenarios. The question what comes into the mind that is this a magic or what is this how is this happening? So is this magic? No, it is obviously it is not a magic. The process of machine learning is very much relatable to the gardening process, where the algorithms and the data are used to generate the required or the desired output, I would say, to meet the end user requirement, right? So an instance of machine learning use in a practical scenario is shown in the figure over here, where the task over here is to identify the number two, right? The number two. I have highlighted this on the top of this figure. You can see that the task over here is to identify this number from a given set of data. So obviously we need a training data and a testing data to develop an algorithm, and then we can predict the figure which can be categorized as the number two, right? So obviously the training and the testing of the algorithm describes and decides the accuracy rate and the error rate of the algorithm. And we'll be talking about the accuracy and how the algorithms are evaluated, but we will come to that part of the problem a bit later. But for now, with this discussion, it should be clear that the general idea of a machine learning scenario is must be clear by now. So you can visualize the application of the technology in real world. For instance, the web search or the computational biology or the finance or the e-commerce, space exploration, robotics, information extraction, social networks, debugging, and almost all these applications. These are some of the very few applications which I have highlighted over here, but they can be many more. There are many more applications. For example, the pattern recognition, in where facial identities or facial expressions are identified. Similarly, handwritten or spoken words are identified. Medical images are identified. Then we have another example as generating patterns. For instance, the motion sequences are part of this entire scenario as well. If you are going to talk about examples, let us talk about recognizing anomalies in a pattern or something. So unusual sequences of credit card transactions or unusual patterns of sensor readings, they are also part of this entire they can be part of this entire discussion. Again, we're talking more about examples we have apart, and see, I'm talking about all these all whatever I'm describing is apart from the applications which I have mentioned over here. So again, we have some of see, the applications are many. Almost everything we see, we do right now, or we are doing right now, or we are involved with, are basically part of in one or the other way, they are part of the machine learning scenario. For instance, the prediction of stock market and all those currency exchange rates and all these things are part of this machine learning and prediction, this artificial intelligence. So if you are interested in some web-based examples of machine learning, then there are many such examples, and this is because the web contains a lot of data, right? So tasks with very big data sets often use machine learning, especially if the data is noisy or that if the data is non-stationary. Now, these examples can be recommender system, information retrieval system, spam filtering, fraud detection, data visualization. All are part of this. So, with all said and done, all the machine learning algorithms have basically these three components, which I have highlighted on the screen over here. And I've shown on the screen over here. The first is the representation, right? So the idea in this, see, any machine learning algorithm can have these. It will usually have these three components. As I said, representation, evaluation, and optimization. Basically, these three are the building blocks of any of these algorithms, which we'll be talking in the upcoming slides, or which you might be working with. So, as far as the first one is considered, so the first is representation, where the general idea in the representation is the representation of data, right? The data correlation, useful information in the data, or the probability of occurrence of it, or of a certain event, or all these are part of this concept. uh, these are some of the parameters which are frequently used by the algorithms when you talk about the representation component of the machine learning algorithms. Now, when we talk about there are so many methods which can be used for representation and that component of the machine learning part. They can be decision trees, they can be graphical models, they can be support vector machines, and all those things. Now, for when we talk about these, the idea is quite clear that support vector machines deals with the classification of the data based on the support vectors, right? The decision trees over here, they calculate the entropy and similar concepts for reaching the optimized decision for classification, right? So in over here, an example of decision tree is shown over here. You can see that the idea is to reach a final decision, whether you can consider me, you can consider yourself in this picture, and the question is very much valid, that should I wait at this restaurant for a certain duration or not. So these are the questions which we need to ask to reach the final outcome, yes or no. So these are some of the questions. If we have a favorable response at a certain, let us say, at the first question we have, what is the estimated time, what is the alternate, are we hungry, if we are hungry, then what is the alternate, or if the wait time is between 30 to 60, let us say, minutes or minutes, then what is the alternate? Do I have a reservation? Is it a Friday or Saturday? So finally it comes to so many things when we talk about reaching a final conclusion. And all these splitting of these cells is made on the basis of the useful information content, entropy, and all these concepts come into the picture when we talk about decision tree and the splitting of attributes, right? The information gain, the entropy, and all these things are important concepts associated with it over here. For instance, I was talking about the Bayesian networks. Now, Bayesian networks are also they are based on the computation of conditional probability and joint probability of certain events. For instance, the what is the probability of occurrence of a specific event if a certain event, if it is guaranteed that a certain event has already occurred, right? For instance, if there is an earthquake, what is the given that a earthquake has taken place, what is the probability of alarm could that the alarm will go off, or what is the probability of given that a burglary has already happened and the alarm will go off. Or you can also ask questions like this, that if given that the alarm goes off, what is the probability that the neighbor will call for the police, or similar questions. So conditional probability is involved in this. And this is one of the many examples which I was saying, how these decisions are made, how the algorithm calculates what will be the final outcome. So Bayesian networks are also an example of this. So as I was saying, the second component of these machine learning algorithms is the evaluation. So the evaluation of these algorithms or these methods or these techniques can be done on several parameters, right? These parameters are basically, this is what you are expecting basically this is what you expect from any of the algorithm or methods or the technique which you devise. You need a high accuracy, right? Obviously you have devised an algorithm, so to do you have written this algorithm for doing a certain task. So if that task is not done with accuracy, it is a bit of a trouble for us, right? Then we have precision, then we have squared error, then we have posterior probability, we have cost, we have margin, we have entropy, we have, there are so many parameters on which these algorithms can be evaluated. One of the parameters, for instance, is I have included one of the parameters, and these parameters can be many, right? So one of the parameters is, for instance, the classification accuracy. What is the classification accuracy of an algorithm given a classification accuracy and coverage versus coverage graph is presented over here. What is the amount of coverage and corresponding classification accuracy accordingly, right? So on the there are so many more parameters. For example, the triple trade-off in the empirical learning. This is also one of the accuracy measures. So there are, what I'm trying to explain over here is that there are so many methods, so many ways in which the algorithms can be evaluated, and that depends upon the kind of application for which this program, this algorithm, this method is being developed. Then again, the third component is the optimization. Now, optimization is an integral part of machine learning algorithms because these optimization can be achieved in so many ways. A convex optimization, for example, the gradient descent, greedy search is there, combinatorial optimizations, and then constrained optimization. So these optimizations can be achieved in so many ways. So these are basically the three components which form any of the machine learning concepts and the algorithms or the methods which we might have seen, which we might want to work on, or which we might try to develop in the upcoming future. Then finally, I'd like to quickly go through the types of machine learning algorithms or machine learning methods. So basically, we have three ways. I have incorporated three ways: supervised learning, unsupervised learning, and reinforcement learning. Although in the current research scenario, there are so many more scenarios which have been included in the machine learning scenario. For instance, the transfer learning is there, and similarly there are so many more methods and more learning scenarios which have been included into the machine learning scenario. But for now, I have included only these three, which are supervised learning, unsupervised learning, and reinforcement learning. So as far as supervised learning is considered, as the name indicates, the as the name indicates, it is basically the presence of a supervisor or the learning takes place in the presence of a supervisor or a teacher, let us say. So basically, supervised learning is a learning in which we teach or we train the machine using the data which is well labeled, right? That means some data is already tagged with the correct answer. After that, the machine is provided with the new set of examples or examples, that means data, so that the supervised learning algorithm analyzes the training set or the, for instance, the training example, and produces a correct outcome from the label data. If you want to consider an example for this, for instance, you can consider the example of a basket which has so many different kinds of fruits. Now, the first step is to train the machine with all the different fruits one by one. uh, and if the shape of the object is round and it is on some it has certain color, then it can be labeled as an apple. If the shape of the object is long and something, it has a specific color, green, yellow or something, it can be labeled as a banana. And similarly, when the machine learns this, if it will first classify the fruit. Whenever a new data is provided to the machine, it will first classify the fruit with its shape and color, and it would confirm whether the fruit is banana or and it will classify it into a designated category. So, having said this, the second kind of learning is the unsupervised learning. As the name indicates, the type of learning which we are going to deal with. The unsupervised learning is the basically the training of machine using information that is neither classified nor labeled, and this allows the algorithm to act on the information without any guidance, right? So here the task of machine is to group unsorted information according to similarities, patterns and differences without any prior training of the data, right? So unlike supervised learning, no teacher is provided. That means no training will be given to the machine. What is meant by this is that the machine is restricted to find the hidden structure in the unlabeled data by itself, right? For instance, I'm quite sure that you must have heard very so many examples of clustering and associations and all these. So these are part of the unsupervised learning. So finally, we have reinforcement learning. I have tried to incorporate reinforcement learning over here. So I'll go through the example of reinforcement learning in a bit detail, so that this concept is clear. So it is basically reinforcement learning is about taking suitable actions to maximize the reward in a particular situation, right? It is basically it is employed by various software and machines to find the best possible behavior or best possible path the machine should take in a specific situation. Now, as far as the differences from the supervised or unsupervised learning is considered, so how is it different from a supervised learning and how is it different from a unsupervised learning? So I think the idea should be quite clear that in supervised learning, the training data has the answer key, right? Answer key associated with this, so that the model is trained, right, with the correct answer itself. Whereas in the reinforcement learning, there is no answer, but reinforcement agent decides what to do or what tasks to perform for a given job, right? In the absence of a training data set, it is bound to learn from its experience. Obviously, this is quite a straightforward deduction, which I just said. But then again, consider the exam for a better understanding of this concept. Consider the example which is shown over here. Or okay, I'll come to this example, but okay, I'll try to explain this with a different concept. Okay, for instance, we have an agent and a reward, right? And there are many hurdles in between, right? So the agent is supposed to find the best possible path to reach this reward, right? To have this, I hope this clears the picture which I'm trying to present over here, because it is more or less the same thing. To because the image shows a robot over here, a diamond, and a fire. This is the reward. These fire images or blocks can be considered as hurdles in the path of this robot reaching the diamond, right? So the goal of the robot is to get the reward, that is the diamond, and avoid the hurdles, that is the fire over here. So the robot learns by trying all the possible paths and then choosing the path which gives him the reward with the least hurdles, right? So each right step will give the robot a reward, and each wrong step will subtract the reward of the robot. So this is what reinforcement learning is about. The sorry sorry So the total the total reward will be calculated when the robot finally reaches to the final destination. So the main points to remember in reinforcement learning are regarding the input, regarding the output, regarding the training, regarding the learning, and regarding the reward. So these are basically five things which can summarize the entire reinforcement learning concept. For instance, the first one is input. When I say input, I mean to say that the input should be an initial state from which the this model will start. Then we have the output. There are many possible output, as there are variety of solutions to a particular problem. But then again, this need to be addressed. And finally, we have the training. Now the training is based on the input. The model will return a state, and the user will decide to reward or punish the model based on its output, right? And finally, this model continues to learn. There is a continuous learning based on the steps taken by at every iteration, right? The best solution is decided based on the maximum reward which can be achieved by reaching the optimal solution. So I have included one of the examples, one of the day to day, although it is not considered with the uh, this concept of reinforcement learning, but this concept of association. So I hope the idea of reinforcement learning is quite clear. So having discussed all these three, I have included example of learning associations over here. Association analysis is a very common example of machine learning or association learning in as far as in our day-to-day life is considered. The market basket analysis, most of you who yeah, have worked in data mining or have seen the data mining things work, you'll realize what market basket transaction is. So for those who are unaware of this, I'll quickly go through what market basket transaction is. For instance, you visit a supermarket and you say that you see that all the products are lined up in different aisles, right? So you won't find a bread placed just beside a toilet cleaner. If you pay attention to this, you will never find this. You will never find a television placed just beside the vegetable counter. So when you visit all these supermarkets, for instance, the Big Bazaar, the Spencer, or any of these supermarkets in which uh, multiple commodities are sold, best price and all these. So you'll realize that they are placed in a definite order. And how do they these vendors or these organizations come to this? Because obviously they have invested some time, invested some energy in identifying the patterns associated with with the items which are purchased together, right? So obviously, bread. The person who is purchasing a bread will not. There is a very small probability that the person has entered into the supermarket to buy a bread, and he or she will purchase a television set along with it, or a toilet cleaner along with it. However, it is quite possible, it can be said with a very high probability. Just I'm not talking about any data, I'm not talking about any set of training set of data, or any test any number of sample data, but I'm just talking about the general assumptions which we can make in our mind. If we think of bread, we think of butter, or if we think of bread, we think of milk, or if we think of bread, we think of jam, or something similar to that. However, in all these scenarios, you will never find when you think of a bread, you will never think of a television, or a toilet cleaner for that matter. Or similarly, whenever you go to the market for buying a potato, you would never think of buying a television or a washing machine or something similar to that. There might be cases when you go to these markets and you are out there for purchasing a long list of items, आप खरीद सकते हैं, there is no issue in that. But this the probability of this occurrence is very less. So this is what these associations are to be analyzed. The algorithms are there for analyzing these patterns and generating a probability of two things to be purchased together, three things to be purchased together, or the probability of a certain transaction to happen given the previous set of transactions available with us. So, having said this, this was one of the examples which I wanted to discuss before moving to what fairness in machine learning is, and what is this is what I was hoping to discuss in a bit of a detail today. But considering the amount of time which we have, I'll cover the basic concepts of fairness in machine learning. I'll talk about the general concept of fairness in machine learning. So the first question is, what is fairness in machine learning? That is an important concept. And then the second question is that we need to ask ourselves, why do we care about fairness? Why fairness is important? Now, the main if you think of fairness in machine learning, why is it important to us? You'll see that the main motivation is that it is highly related to our own benefits, right? Because machine learning systems have been an inseparable part of our daily lives now. They are becoming even more widely used in the they will be more widely used in the near future, as because you can see there are so many practical applications in which these are machine learning applications are being used, being incorporated every day. The machine learning and AI are basically they are a household name now. Now, algorithms are being used for making movie recommendations. They are being used for suggesting what products to buy. They are being used for deciding the when you apply for a loan, or for when you apply for a job. The algorithms are being used over there. What is the probability that you will stay in that organization? What is the probability that you will return back the loan in time? And all these calculations, computations are performed by the algorithms. So there is a clear benefit that or there is a clear picture that the use of algorithm has given us advantage. Now, what are these advantages? For example, the if people are involved in it, in all these processes, they'll get tired or bored. But unlike people, machines do not get tired or bored, and can take as much amount of work as you can give them, and as many factors as you can give them. They won't be affected by them. So obviously, the machines have a clear cut advantage over this. However, like people, these algorithms are vulnerable to biases. Now, these biases affect their decisions, and thus they are called as unfair. Now, if you look for a specific definition for the for this for the bias or for biased algorithms or unfair algorithms or such terminology, then in the context of decision making, I'm strictly talking about the concepts of in the terms of decision making. Then fairness is nothing but now fairness has a there are so many definitions, there are so many ways in which fairness can be defined, and I'm strictly talking in the context of decision making. Then fairness is defined as what? Absence of any favoritism, right? One can be said one can be considered as a fair person if there is absence of any prejudice or any favoritism towards any individual or a group of people or set of characteristics or set of traits which the person or which the people group of people might have. So the same goes for the machine learning algorithm, where we can say that when we talk about the decision making, when we talk in the context of decision making, we can clearly say that fairness is defined as the absence of favoritism or any prejudice towards an individual or a group of people on their characteristics, traits, or any kind of such things. So thus, what we can say is that an unfair algorithm is one whose decisions are skewed towards a particular group of people, right? Thus, it is quite obvious that the AI is good, but it can be used incorrectly, right? As we have already seen, machine learning relies heavily on data, and the data is provided by provided by humans can be highly biased, right? So with this, I think the assumption should be quite clear that with the widespread use of the AI systems and the applications in our daily lives, it is important to take fairness issues into consideration while designing and engineering these types of systems. So, so the question arises: why, or more importantly, how the bias is introduced into the data, right? So when I talk about bias in the data, so these are the two most prominent question which comes into my mind, that why, and then again, more importantly, how the bias is introduced into the data. So the answer to that is that data, especially the big data, is often heterogeneous, and it is generated by subgroups which have their own characteristics and behaviors. To or in the simplest of words, if I say, then heterogeneities can cause bias in the data. Because of heterogeneity, there can be a bias in the data. And if a model learns on a biased data, it may lead to unfair or inaccurate predictions. To illustrate how biases in the data affect machine learning, I have taken an example over here. You can see there are two predictions, two figures shown on the screen. Now this is about this is about a nutrition study which measures how the outcome or the we are aiming for a body mass index in these figures. So the outcome is the body mass index. So the aim is to detect how the outcome changes as a function of daily number of calories taken by the person. Now this is the results are reflected over here. The regression analysis, the solid red line, as you can see on the screen, shows a positive relationship in the population between these variables. Now the positive trend suggests that the increased let us say pasta, or let us say whatever is the diet. So increased pasta consumption is associated with higher higher BMI, right? And I'm using pasta because this is not my study. I have borrowed this figure from a research paper. They have conducted this study and they have taken pasta as an example over here. So I'm taking the same example at this point. So as I was saying, the positive trend in this figure suggests that this pasta consumption is associated with the higher BMI, right? However, in this study, it was not told to the researchers. Initially, it was not allowed. The researchers were unknown to this fact that the population on which this data is being from which this data is being derived, or the population of the data, the study population was heterogeneous. And when I say heterogeneous, that means it was composed of subgroups that vary in their fitness level. People who did not exercise, people who have normal activity levels, people who were athletes, and every kind of combination was there. So when the data is disaggregated by the fitness level, the trends with each subgroup are negative. The dashed line, which you can see over here, leading to the conclusion that the increased pasta consumption is in fact associated with a lower BMI. Right. So you can see kind of analysis, there is one recommendations for the pasta consumption when it was done when it was done with a naive analysis. The recommendations were different, but when we had a closer look, the output was different. So therefore it is the naive analysis is exactly the opposite of more careful analysis that accounts for the differences between the subgroups. Therefore, from this example or from this figure, it must be clear that it is fair to say that bias in the data can exist in many shapes and forms, and some of which can lead to unfairness in different learning tasks, for instances, right? So as far as these biases are considered, these biases can be many. There can be a historical bias. There can be a historical bias. Now, historical bias is a bias in historical bias is already existing bias, and socio technical issues in the world can see into from the data generation process, can even given a perfect sampling and feature selection then also. So again, then there is representation bias, there is measurement bias, and there are so many kinds of biases which can be given. So as far as the algorithmic fairness is considered, is we can say that the machine learning is used in different applications. For example, in courts, to assess the probability that a particular person will recommit a crime. If it is used to in different medical fields, in childhood welfare systems, in autonomous vehicles. And what you'll realize that in all these applications, what you'll realize that all of these applications have a direct effect on our lives and can harm our society if not designed, and these applications are not engineered correctly, right? And when I say correctly, that means with a fair consideration to the this fairness concept. So if you look closely, you will see that you can actually prepare a list of applications and the ways in which these AI systems affect our daily lives with their inherent biases. For instance, there was an example of a there are so many example of algorithmic biases in the current scenario. I was hoping to get a detailed discussion about. I was hoping to discuss in detail uh, a bias which is very popular in a software which is called Compass, but I'll not cover that considering the time frame which we have. So, as I said earlier, mm, broadly, what I was trying to say is that fairness is absence of any prejudice or favoritism towards an individual or a group based on their intrinsic or acquired traits, right? In the and when this is what when we are talking about the when we are talking about decision making. Now, even though fairness is incredibly desirable quality in the society, it is surprisingly difficult to achieve it in practice, right? In order to understand how we can have so many definitions of fairness, it is crucial to understand that some to understand the different kinds of discriminations that may occur, because fairness can only be justified when we have different kinds, when we are aware of different kinds of discrimination. Now these discriminations can be so many. For instance, direct discrimination, indirect discrimination, systematic discrimination, statistical discrimination, and many more, right? For instance, the systematic discrimination refers to policies or behaviors that are part of the culture or the structure of an organization that may result in a discrimination against certain subgroup or the population. For example, a restaurant which is fulfilling customers' requests that led to a discriminatory placement of employees would be a systematic discrimination. For instance, the statistical discrimination. Statistical discrimination is a what should I say? It is basically a phenomena where decision making the decision makers use average group statistics to judge an individual belonging to that group. Now, there have been numerous attempts to address bias in the artificial intelligence and machine learning, but in order to achieve fairness, the idea is that these all these methods target bias in the algorithm, and these methods can thus be classified in basically three categories. There can be they can be pre they can target bias in the algorithms, and these can be classified generally in three categories: the pre-processing, in-processing, and post-processing. So, as far as pre-processing techniques are considered, the pre-processing techniques try to transform the data so that the discrimination is removed in the early stages itself. And then we have in-processing. The in-processing tries to modify and change the state-of-the-art learning algorithms in order to remove the discrimination during the training model training process, right? And finally, we have the post processing, in which after the training by accessing a holdout set which was not involved during the training of the model, post processing is implemented, right? So to conclude, I will say that while there have been many definitions and approaches to fairness in the literature, but again, there are so many aspects on which we can work on. Several definitions or there are several challenges which need to be addressed in fairness. For instance, the synthesizing a definition of fairness, and then several if you see that there are several definitions of what would constitute fairness from a machine learning perspective. But these definitions cover a wide range of use cases, and the result are not very appropriate in and I'll not say appropriate, but they view fairness in a totally different perspective, and hence it is different to integrate them together. Because of this, it is nearly impossible to understand how one fairness solution would fare under a different definition of the fairness, right? So synthesizing these definitions into one remains an open research problem. And then there are so many issues. I'm highlighting one or two issues. So search for unfairness is another issue which I have highlighted over here. Now, given a definition of fairness, it should be possible to identify the instances of this unfairness in a particular data set. However, there are so many different ways in which this can easily become a fair research problem. And hopefully, if you start working on fairness if you are working in machine learning or artificial intelligence, you will definitely try to incorporate uh, fairness in your machine learning and AI approaches. So this will be all for today. Thank you so much for being over here and such a patient listener. Thank you so much. So, any questions or
Thank you, sir. You have shared valuable information with us. Thank you so much for your time and for your presence.
Thank you so much, ma'am. Thank you for having me here.
So, this is the last session for RAICT for today, and we will be live tomorrow for more sessions related to recent advancements in information and communication technology. Have a great day, and you can find the links for tomorrow's session in the comment section. And you can also check our website for the symposium where we have all the information related to the symposium. If you want to register for attending our symposium, then you can check our website for the registration link and other informations. Thank you so much. Have a great day.